Okay, and then here's our other one. This is your second go around for the rational expressions. Now, multiplication is 3 steps. Okay, you don't need Math Papa to do this. It's not going to be any good on this part. Okay, so I need to parenthesize where we have this. That probably can be factored. I know that can. This can probably be factored, and this really can't, so I'm just going to carry that one over here. Okay, and this can be pretty miserable, I'll admit. 3x to the second plus 4x plus 1. 3 terms, so GCF and the T-chart. Okay, GCF, we don't have one. Then I multiply the A and C coefficients. That gives me positive 3. Sum of 4, and that's 1 and 3. Okay. A is 3x squared here, so we're going to need definitely 4 parentheses. So I go 3, 3, x, x, 1, 3. Okay, so we got plus 4x, so they'd have to both be positive. And this one here can't be done, but you can divide this by 3, and that's 1x plus 1. Okay, so up top we got 3x plus 1, and then 1x plus 1. Okay, another trinomial here, x second plus 8x plus 12. That's 3, so okay, and the GCF is no-go. A times C, 1 times 12 is positive 12, so I'm looking for a sum of 8. Got it, okay. A is 1x squared, so that's good, so I can just write it as but 2 binomials with x times x. Okay, so plus 8x and plus 6. Okay, so on top we got x plus 2 and x plus 6. Now this right here is an obvious DOPS, 2 times 2 and x times x. So I go make 2 parentheses, x, 2 and 2. Okay, now cross out parentheses that you would have. So the 1x plus 1 and 1x plus 1 can cancel, and the x plus 2 and x plus 2. And then there's really no outside things I need to look at, so I put NA there. And I've got 3x plus 1 and x plus 6 over the binomial x minus 2. Okay, another multiplication one, 1, 2, and 3, but there are no adding and subtracting within those expressions, so I don't really need to factor anything. I do have everything outside, though, so I got to put it together. So I've got 10. X fourth and x is x to the 5th, and then y to the 4th. And then bottom with 3 times 6 is 18. And then x and x to the second is x to the 3rd. Y to the second, y is y to the 3rd. Now we can divide those by 2, so that's 5 and 9. And then x fifth and x third. Get rid of the x to the 3rd and then subtract 3 from that. That's 2. Subtract 3 from your 4, and that's a 1. So I've got 5 ninths, x to the second, y to the 1st. You can also just put y. Okay, right here, I need to solve for x, and there are only 2 ratios, so I can just label this A, B, C, D, and use my diagonal multiplication to solve it. Okay, so A, B, C, and D. So A times B, 1 and 7x, and then 2 gets multiplied by 1x plus 5. So that's 7x, and that's going to be 2x plus 10. So get your x's on the same side. 5x equals 10. I divide by 5, and 10 divided by 5 is 2. Okay, next one. Well, this time there's 3 ratios, okay? So I'm going to need to extend those out. And I will need to come up with an LCD after I make sure everything's simplified here. So 12 just drops. This would get parenthesized, and it's a difference of perfect squares because we got 1 times 1 and x times x. So I need to write that as x plus 1 times x minus 1. And the 2's just dropped. The 3x is dropped. Now this would go in parentheses, but it's nothing we can do to factor it, so that will stay the same. Okay, so really the only thing I have to really worry about, folks, is the x plus 1 and our x minus 1. X plus 1, 1, 0, 1. So, okay, x minus 1, 1, 0, 0. Okay, so I need to put another x minus 1 and an x minus 1. X minus 1 and an x minus 1. So I drop my equals, and now I use my math papa, okay, with the LCD stuff when you have all these parentheses, okay, it makes it a lot easier. Okay, so on one side I've got 12 plus 2 times x plus 1, and then x minus 1. Okay, I got 2x to the second power plus 10. Okay, and let's see what we got going on in here. Some of you already know it's 3x squared minus 3x, but I'm going to check just to be sure. If I got technology, whoa, I might want to make sure the mouse is on that. Three x squared minus 3x, okay. Okay, so we got x squareds and we also have x, so let's move everything to one side. Now let's move the smaller x squared out of there because I don't really like having negatives in front of x squareds when I go to factor. That 10 would just go beside everything. Okay, so I have 1x to the second minus a 3x minus 10 equals 0. And then I factor the trinomial, GCF and T. GCF is a no. Okay, A times C, 1 times negative 10. That gives me a negative product, so it's a difference. That would equal 3. And 2 and 5. And A is 1x squared, so I just need 2xx, 2 and 5. Minus 3, so you got minus 5, and difference would be plus 2. Okay, so x plus 2 equals 0. I got to add a second answer to that. X minus 5 is 0. Minus 2, I get negative 2 and 5. Okay, story problems. I've connected on 18 to 25 serves in volleyball. How many consecutive serves do I need to make to raise my average to 85%? So what do I want my percent to be? I want it to be 85 over 100. Okay, I've made 18 of 25, so what I need to do is add an x here. It's a 1x, and that will then add an x to the attempts. So there's only 2 ratio lines, making this pretty easy to handle. And I will be taking 18 plus 1x, that gets multiplied by 100, and then I'll be taking 85 times 25 plus 1x. So 18 times 100 is 1,800 plus 100x. 85 times 25, 2,125. Okay. All right, so I want to get my x's on the same side because they're like terms. So 1,800 plus 15x equals 2,125. And then I subtract 1,800. So 15x equals 325. Divide by 15. Okay, 22 is how many I'd have to hit. Okay, between 21 and 22, but 21 wouldn't be enough, so it's better to go over. Okay, now the next one. Two planes travel for equal amounts of time. Okay, that's important. First plane travels at 600 miles. The second plane travels 750 miles. If the second plane travels an average of 25 miles per hour faster than the first, what's the time they're in the air? So hours. Now they're in the air for the same time, so there's only one answer. Hours and miles. Yes, there is a shorter way to do it, but it has to make sense to the people using it. Okay, miles per hour, I see miles per hour, but then afterwards I see it faster. So x plus 25 and x will represent the miles per hours. So remember, when I solve for x, I have not found the hours, I've found the miles per hour. Okay, now without any hours of travel, we're not going to get any mileage, so it's direct variation. So that's ratios, it's only two planes, okay? And it says that times were equal, so that would mean the distances over the speeds are equal, okay? I'm just going to leave these variables the way they are. The distances can be replaced, okay? Because we know them. We have 600 and 750. And the one with 750, instead of x's, we'll just leave them as s's, and we'll just put plus 25 with the higher distance, okay? So A, B, C, and D. Okay, remember those are s's, not 5's. It doesn't matter if it's x or s. It doesn't really matter. Okay, so 600 is going to be multiplied by 1s plus 25, and then the 750 is going to be multiplied by 1s. Okay, so 600 times 1s is 600s, and then 600 times 25 is 15,000. And then 750s. Okay, get your s's on the same side because they're like terms. Okay, so 15,000 equals 150s. So I divide by 150, and I take 150,000, divide by 150, and that is 1,000, okay? Wait a second here, 600. It's 100, sorry, I got that wrong. S is 100, so the speed's 100. Okay, now that's not the hours though, so what I do is I put 100 in for these S's up here, and I got to make sure they're equal. So 600 divided by 100 is 6, and 750 divided by 125 is 6 as well. Okay, so 6 hours. I got the 6, I put 100 in for the S's and then divided. Okay, number 7, 2 friends can mow 4 fields in 5 hours. If one friend's mower goes twice as fast as the other, how long would it take them working separately? So how long means the hours, but there's 2 of them because they work at different, it's going to take them different times here. Okay, so I've got hours and fields. It's X, it's Y, so per fields per hour, and I don't know that. I know nothing about that. You can write 1 line or 2 lines, but it's not going to matter because with 0 hours, you're not going to get anything done, okay? So it's direct variation. Now, we need 3 ratios here because we got the 2 separate ones and then the together. Now, remember to put your hours on bottom. It has to be that way. The time has to go in the denominator because fields per hour. So when they work together, they can get 4 over 5 done. And then if they work separately, they'd still have to get 4 fields done. But I don't know the hours, but I know that one goes twice as fast. So 2x and x. Okay. So this time there's 3 ratio lines. And we'll just drop everything down. And I need to come up with an LCD. There's no parentheses, so it's all outer, okay? So I've got outer X, got outer 2 on the bottom, and outer 5. Remember, those 4s are on top, so they don't matter. So outer X, I've got 110. Okay, so I need to put X and X. Outer 2, 100. So I will need to multiply by 2 and by 2, by 2 and by 2. Outer 5, 0, 0, and 1. Okay. Okay, so times 5 times 5 times 5 times 5. And then this is out, okay? And then 4 times 5 is 20. You don't need Papa Math because there's no parentheses. You have to FOIL and multiply. Okay, 4 times 2 is 8, times 5 is 40, and then 4 times 2 is 8, with an x behind it. Okay, so it's going to be 60 equals 8x, and then divide by 8. You get a decimal, that's okay. 7.5, so it takes the faster guy 7.5 hours, and then the other guy, he's slower, so we'll double his time, and that's going to be 15, okay? All right, and then there's that other video you want to click on for the distance speed time table with the wind speed.